Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to give you some additional guided practice using the PITA method to solve some challenging problems that may appear on the Armed Services Vocational Aptitude Battery. As always, I strongly encourage you to work out these problems on your own scratch paper. That is, after I read each question, you should pause the video, attempt to work out the problem on your own, and then resume playing the video to check your solution. The reason I'm making this video is because I did a poll yesterday, and about 93% of you said you wanted more practice using the PITA method. Again, about 3 weeks ago, I uploaded a video in which I first discussed this method, and it's very easy to use. PITA stands for plug in the answers, and basically you take your answer choices, plug them into the equations you're given, and once one of those answer choices makes a true mathematical statement, you know it's correct. Before we get started today with today's video, I just want to issue you a word of caution. The PITA method is not the most efficient way to solve these problems. Instead, it's a method you can use in the event your mind goes blank as you look at a question on test day. So, for example, if you forget how to solve a system of equations algebraically using the substitution or elimination method, you can revert back to the PITA method and get the question right. So, all that being said, let's go ahead and get started with today's video. All right, so the first question says, solve the following system of equations. As you can see, we have 2x plus y equals 9 and 3x minus y equals 16. During this video, I'm going to stress this over and over again. The most efficient way to solve this problem is algebraically using either the substitution or elimination methods. That said, if on test day you see a problem like this and your mind goes blank, you can revert back to plugging your answers into the equations to see which one makes a true mathematical statement. That is the PITA method. So let's go ahead and do that. Again, we're dealing with ordered pairs as our answer choices, and ordered pairs are always x, y, and so we're going to take our ordered pairs and plug them into one of these equations accordingly. And once we get a true mathematical statement, we'll be done. This top equation looks like it's the easier of the two, so I'm going to use just this top equation to start. So let's go ahead and do 1, 3 first. Again, 1 is our x and 3 is our y. And we're just going to plug that into this top equation, which is 2x plus y equals 9. Again, in place of x, I'm going to put 1, and in place of y, I'm going to put 3. So let's go ahead and do that as our next step. We have 2 times 1 plus y is 3, so that's just 3 there, equals 9. 2 times 1 is 2, plus 3 equals 9. 2 plus 3 is 5. 5 equals 9. Is this a true mathematical statement? Does 5 equal 9? It's not. Therefore, we know 1, 3 is not a solution to this system of equations. Again, we took our answer choices, we plugged them into the original equation, and we looked to see if we got a true mathematical statement. Since we did not, we know it's not correct. So let's do the same thing with answer choice B. Again, B is 2, 3. Again, we know 2 corresponds with x, whereas 3 corresponds with y. And to keep things simple, we're going to plug those values into the easier of the two equations, notably 2x plus y equals 9. In place of x, I'm going to put 2, and in place of y, I'm going to put 3. So this becomes 2 times 2 plus 3 equals 9. Okay, so 2 times 2 is 4 plus 3 equals 9. 4 plus 3 is 7. Does 7 equal 9? It doesn't. So this is not a true mathematical statement. And in light of that, we know B is incorrect either. Let's go ahead and do the same thing with 2, 4 now. So we got the ordered pair 2, 4. Again, 2's are X, 4's are a Y. And we're going to plug that into 2X plus Y equals 9. Again, in place of X, I'm going to put 2, and in place of Y, I'm going to put 4. So this becomes 2 times 2 plus 4 equals 9. 2 times 2 is 4, plus 4 equals 9. 4 plus 4 is 8. 8 equals 9. Does 8 equal 9? No, that's not a true mathematical statement. So at this point, we can confidently say that D is the correct answer choice. That said, let's go ahead and plug it into the equation just to verify that. So again, we have the ordered pair 5, -1, and we want to check to see if it's a solution to this system of equations. We know 5's are X and -1's are Y, and we're plugging it into 2X plus Y equals 9. In place of X, we're going to put 5, and in place of Y, we're going to put -1. So this becomes 2 times 5 plus Y is -1, so that's -1 equals 9. This becomes 2 times 5, which is 10. This is just -1 equals 9. 10 minus 1 is 9. 9 equals 9. This is a true mathematical statement. 9 does, in fact, equal 9. So therefore, we know D is the correct solution to this system of equations. All right, this second question says, write the equation of a line given that one point on the line is 1, 6, and another point on the line is 3, 2. So again, I strongly encourage you to solve this one algebraically by finding the slope first and then plugging the slope as well as one of these ordered pairs into the point slope equation and solving it algebraically. That said, things do happen on test day, and so in the event your mind goes blank on test day, you can use the PITA method to solve this one by plugging these ordered pairs into our answer choices. So let's see what that looks like. Again, the goal of the PITA method is to plug values in for X and Y and make a true mathematical statement. Ordered pairs are always of the form X, Y. So in light of that, we know this 1 is the X, this 6 is the Y, this 3 is the X, and this 2 is the Y. You really only have to plug one of the ordered pairs in to start, and if it makes a true mathematical statement, you can plug in the other one to double check it. If it doesn't make a true mathematical statement, you know it's not correct. So let's see what that looks like. Again, I'm going to start by plugging 1, 6 into this first equation, notably y equals -2x plus 8. Again, we know 1's x, 6 is y. In place of y, I'm going to put 6, and in place of x, I'm going to put 1. So this becomes, and I'm going to drop down a line here, 6 equals -2 times 1 plus 8. Let's just keep working out this right-hand side of the equal sign to see if we make a true mathematical statement. So we have 6 equals -2 times +1 is -2 plus 8. 6 equals -2 plus 8 is 6. So we have 6 equals 6. That's a true mathematical statement. So there's potential for A to be the correct answer choice. That said, whenever you're given two ordered pairs and you want to test them using the PITA method, I strongly encourage you to use both of them in the same equation. So let's go ahead and do that. Now we're going to test this second ordered pair. And we have x here and y here. And we're going to plug it into this first equation still. So it's going to be y equals -2x plus 8. It's possible that one ordered pair makes a true mathematical statement and the second ordered pair does not. If that's the case, it's not the equation of the line, and you would have to move on. So let's go ahead and keep testing this one. In place of x, or in place of y, we're going to put 2, and in place of x, we're going to put 3. This becomes 2 equals negative 2 times 3 plus 8. So we have 2 equals negative 2 times 3 is negative 6 plus 8. 2 equals negative 6 plus 8 is 2. So we have 2 equals 2, which is a true mathematical statement. And since both of these ordered pairs make this equation y equals negative 2x plus 8 true mathematical statements, we know that this is the correct answer choice. Since we're practicing, let's go ahead and plug in one of these ordered pairs into D just to see what that looks like. So again, I'm going to plug in 1, 6 into the equation y equals 2x plus 4. Again, we know 1 is x and 6 is y. Plug those in accordingly. We have 6 equals 2 times 1 plus 4. 6 equals 2 times 1 is 2 plus 4. 2 plus 4 is 6, so we have 6 equals 6. Okay, so in this case, this ordered pair works for this equation. That said, you have to test the second ordered pair. So let's see what that looks like. We have 3, 2. We know this is x, y, and we're plugging it into the same equation. Y equals 2x plus 4. Again, in place of y, we're going to put 2, so this becomes 2 equals 2x. In place of x, we're going to put 3 plus 4. 2 equals 2 times 3 is 6, so this is 6 plus 4. And 2 equals 6 plus 4 is 10. Does 2 equal 10? It doesn't, so that is not a true mathematical statement. So in this instance, one of the ordered pairs made a true mathematical statement, but the other one did not. So we know that this equation does not work for these ordered pairs. Again, the equation has to work for both ordered pairs to be correct, which we saw was the case for A. So be careful about that. One of them may work, the other may not. Okay? All right, so for number 3, we have if r squared minus 14r plus 48 equals 0, which of the following shows all of the possible values of r? We have negative 6, 8, 6 and 8, and negative 6 and negative 8. So we should recognize right away that we have a quadratic equation right here. The most efficient way to solve a quadratic equation is by factoring it. If you can factor this, you'd be done in about 10 seconds here. That said, let's say on test day your mind goes blank and you have no idea how to factor this. You could use the PITA method to solve it. And again, the PITA method says take all your answer choices, plug them into the equation, and once you get a true mathematical statement, you'll know that that is the correct answer. So in this case, we're going to start with r being negative 6, and we're going to plug it into the original equation given, notably r squared minus 14r plus 48 equals 0. Again, in place of r, we're going to put negative 6, so this becomes negative 6 squared minus 14 times negative 6 plus 48 equals 0. Let's go ahead and work this out. Negative 6 squared is the same as negative 6 times negative 6. Negative times a negative is a positive, so negative 6 squared, in other words, is positive 36. We have negative 14 times negative 6. I'm going to have to do that off to the side since I can't do that one mentally. And we have 14 times 6. 4 times 6 is 24, so drop down your 4 and carry your 2. 6 times 1 is 6, 7, 8. So negative 14 times negative 6 is positive 48 plus 48 equals 0. You don't have to add these up to see that this isn't going to be a true mathematical statement. 36 plus 48 will never equal 0. But that said, if you want to do the math, you could. We have 48, and 36. 8 plus 8 is 16, 17, 18, 19, 20, 21, 22. Carry your 2. 4 plus 4 is 8, plus 2 is 10, plus 3 is 13. So this is 132 equals 0. That is not a true mathematical statement. Therefore, we know negative 6 is not a possible solution or a possible value of r. And again, negative 6 appears in A, and it also appears in D. So we also know that D is not correct either. So that eliminates 2 answer choices right off the bat. Let's go ahead and test R being 8 next. So let's do it over here. R equals 8, and we're going to plug that into the equation given. Notably, R squared minus 14R plus 48 equals 0. Let's go ahead and check this one out. Again, in place of r throughout this equation, we're going to put 8. So this becomes 8 squared minus 14 times 8 plus 48 equals 0. 8 squared is the same as 8 times 8, which is 64. So this is 64 minus, again, I'm going to work 14 times 8 off to the side. 8 times 4 is 32. Bring down a 2, carry a 3. 8 times 1 is 8, 9, 10, 11. So this is 112 plus 48 equals 0. I'm going to combine these two positive numbers just to see what they are. So let's see what that is. I'm going to add 64 plus 48. 8 plus 4, 8, 9, 10, 11, 12. Carry a 1. 4 plus 6 is 10, plus 1 is 11. So in other words, 64 plus 48 is 112. Then we have this minus 112 equals 0. 112 minus 112 is 0, so this becomes 0 equals 0, which is a true mathematical statement. So we know 8 is a possible value of r. That said, 6 is also another possible value of r, so we have to check it to rule it out. So we have r, and let me write that up here. So we can see it all at once. Let me just make a little dashed line there. We're going to test r being positive 6 now in the equation r squared minus 14r plus 48 equaling 0. Again, I'm going to plug in 6 wherever I see r in this equation. So this becomes 6 squared minus 14 times 6 plus 48 equals 0. 6 squared is the same as 6 times 6, which is 36. Over here, we worked out 14 times 6. We knew it was 84, so this is minus 84 plus 48 equals 0. Let's go ahead and add 36 and 48 off to the side. Again, we have 36 and 48. 8, 9, 10, 11, 12, 13, 14. Carry your 1. 4 plus 3 is 7, plus 1 is 8. So this is the same as 84 minus 84 equaling 0. 84 minus 84 is 0. So this is 0 equals 0, which is a true mathematical statement. Therefore, we know all the possible values of r are both 6 and 8, since when we plug them into this equation, they both make true mathematical statements. Okay? So that's that one. All right, number 4 says, if the square root of 5x plus 1 minus 1 equals x minus 2, then x equals. So This one should be obvious that we can substitute these values in for x, and whichever one makes a true mathematical statement, we'll know is the correct one. And so let's go ahead and do that. So we're going to let x equal 4 to start, and we're going to plug that into the equation given, notably 5x plus 1 minus 1 equals x minus 2. Let's go ahead and substitute 4 in for x everywhere we see it. So this becomes 5 times 4 plus 1 minus 1 equals 4 minus 2. I'm going to work this out step by step so you can follow along. And this becomes the square root of 5 times 4 is 20, plus 1 is 21. So this is the square root of 21 minus 1 equals 4 minus 2, which is just 2. Here we have to use some of our mathematical reasoning skills to kind of determine what this is. The square root of 16 is 4. The square root of 25 is 5. Therefore, we know that the square root of 21 is going to be 4 point some decimal minus 1 equals 2. Again, 4 point some decimal minus 1 is going to be 3 point something equals 2. Does 3 point something equal 2? It doesn't. So we know 4 does not work as x. So let's plug in 5. So x equals 5. And we're plugging that into the original equation, notably 5x plus 1 minus 1 equals x minus 2. Substitute 5 every place you see x. So this becomes 5 times 5 plus 1 minus 1 equals 5 minus 2. Let's go ahead and take this step by step. 5 times 5 is 25 plus 1 is 26. Minus 1 equals 5 minus 2, which is 3. Square root of 26. Again, we know that the square root of 25 is 5 even, and we know the square root of 36 is 6 even. Therefore, the square root of 26 is going to be 5 point something minus 1 equals 3. 5 point something minus 1 is 4 point something. And does 4 point something equal 3? It doesn't, so we know 5 doesn't work. Let's go ahead and move on to x equaling 6. And we're plugging that into the equation that was given, notably 5x plus 1 minus 1 equals x minus 2. Some bad spacing there. So we have x that we're going to plug in everywhere in this equation. So this becomes 5 times 6 plus 1 minus 1 equals 6 minus 2. 5 times 6 is 30 plus 1 is 31. Minus 1 equals 6 minus 2, which is 4. Again, the square root of 25 is 5 even. The square root of 36 is 6 even. Therefore, the square root of 31 is going to be 5 point some decimal minus 1 equals 4. 5 point some decimal minus 1 is 4 point some decimal equals 4. Does 4 point something equal 4 exactly? It doesn't, so we know that's not the correct answer choice. So we know 6 doesn't work. Let's go ahead and move on to x equaling 7. So we're going to let x equal 7. And let me go up so I can copy down the equation. Notably, I'm going to do it off to the left here. 5x plus 1 minus 1. And let me fix that real quick. Minus 1 equals x minus 2. We're going to plug in x everywhere we see it in this equation. So this becomes 5 times 7 plus 1 minus 1 equals 7 minus 2. 5 times 7 is 35, plus 1 is 36. So this becomes the square root of 36 minus 1 equals 7 minus 2, which is 5. Square root of 36 is 6, so this becomes 6 minus 1 equals 5. 6 minus 1 is 5 equals 5. Is that a true mathematical statement? Does 5 equal 5? It does. So we know 7 is the value of x that makes this equation true. Okay, so that's that one. Again, quite a bit of work to solve this one using the PITA method. For that reason, I recommend you try to solve this one algebraically. But again, if things go wrong on test day, you have this second method you can use to solve a problem like this. All right, so number 5 says solve the following system of equations. As you can see, we have 1, 2, 3 equations and 3 variables, notably x, y, and z. So at first glance, you might be asking yourself, am I going to see something like this on the ASVAB? This looks pretty challenging. Well, the answer to that is yes. If you're going to score somewhere between 90 and 99 on the test, they may throw something like this at you. Again, there are multiple ways to solve this problem pretty easily. You can solve it algebraically using those methods for solving systems of equations. You can solve it using linear algebra, which some people are taught in high school and some people aren't, unfortunately. And then you can use the great equalizer, that is the PITA method, to use some logic to solve this one. Again, in a normal system of equations, you have x, y, and you have an ordered pair x, y as your solution. In this case, our solution has 3 terms, and they're going to be x, y, and z. So in other words, our x corresponds to this -2, our y corresponds to this 3, and our z corresponds to this -3. And by plugging these values into these equations to check to see if they make true mathematical statements, we'll be able to figure out which of them is the solution. So let's go ahead and do that. Again, I'm going to start with A. A says the solution to this one is -2, 3, and -3. Again, this is our x, this is our y, and this is our z. And I'm going to plug them into the easiest of these 3 equations, which I think is going to be x plus 5y minus z. And let me make that a clear z. Z equals -20. Again, just plug in the values accordingly. X is -2, so we have -2 in place of x. Y is 3, so this is plus 5 times 3. And z is -3, so this is minus -3 equals -20. Again, we're checking to see if this makes a true mathematical statement. So this becomes -2 plus 5 times 3 is 15. And this minus minus becomes a big plus. So this is plus 3 equals -20. We can do this mentally. 15 plus 3 is 18. Minus 2 is 16. So this says 16 equals -20. Is that a true mathematical statement? It's not. So therefore, this set of solutions does not work in this bottom equation. In order for this solution to be the answer to our system of equations, it has to work in all 3 equations. If it doesn't work in one, it doesn't matter if it works in the other 2. So since it did not work in this bottom equation, we're going to rule it out as a possible answer choice. Okay? Let's go ahead and move on and check B. Again, B says the solution to this system of equations is -2, -3, and 3. Of course, they're x, y, and z respectively. Let's plug it into this bottom equation since that one was pretty easy to use for this first solution. So again, we're using the bottom equation, which is x plus 5y minus z, and let me make that a z, equals negative 20. In place of x, we're going to put negative 2. In place of y, we'll put negative 3. And in place of z, we'll put 3. So this becomes negative 2 plus 5 times negative 3 minus 3 equals negative 20. Let's work this out. This is negative 2. Positive times a negative is going to be a negative. So 5 times negative 3 is negative 15. Minus 3 equals negative 20. Negative 2 minus 15 is negative 15, 16, 17. Negative 17 minus 3 is negative 20. So we have negative 20 equals negative 20. Is that a true mathematical statement? It is. So in other words, this set of solutions worked in this bottom equation. That said, just to be especially sure that it is the solution to our entire set of equations in this system of equations, you want to check it in the other two equations as well. Again, it could work in this bottom one, but not work in this middle one or top one. So let's go ahead and do that very quickly. But that said, if we get it right here, we'll be done. So again, we're still checking this answer B, and we're checking it in this middle equation now. So it's negative 2, negative 3, and 3. Again, we know this is x, y, and z. And we're going to plug it into this middle equation next to check it. So that's going to be 4x minus 5y. Again, I'm just pulling that right here. Plus 4z equals 19. So this becomes 4 times negative 2. Again, x is negative 2 minus 5 times negative 3 plus 4 times 3 equals 19. 4 times negative 2 is negative 8. Negative 5 times negative 3 is positive 15. And 4 times 3 is 12 equals 19. We can add these two together first. So 15 plus 12 is 27. So this is negative 8 plus 27. 27 minus 8 is 19. So this is 19 equals 19. This is a true mathematical statement. So we know this solution worked in this middle equation. At this point, I'd be inclined just to pick B as my correct answer and move on. But since we're doing this for practice, let's go ahead and plug it into this top equation just to confirm that it is in fact the solution to the entire system of equations. So we have, again, we have negative 2, negative 3, and 3. Again, that's x, y, and z. And we're going to plug it into this top equation, which is negative x minus 5y minus 5z. So negative x minus 5y minus 5z equals 2. And let's plug in things accordingly. We have negative of negative 2 minus 5 times negative 3 minus 5 times positive 3 equals 2. Negative negative 2 is just going to be 2. Negative 5 times negative 3 is plus 15. And then negative 5 times positive 3 is minus 15 equals 2. 15 minus 15, this is 0, so this becomes 2 equals 2. which again is a true mathematical statement. And in light of the fact that this set of solutions works in all three equations, we know it is the solution to our system of equations. So the answer to this one is B. Okay, so that's it for this video. I hope you found it helpful. Unlike the previous video, I included some pretty challenging problems in it, including that very last one, to show you that as long as you understand how the PITA method works, you can use it to solve a wide array of problems. That said, if you like the content I'm creating, please consider subscribing to my channel. In addition, you're more than welcome to leave some feedback in the comment section below. But on that note, I'm going to go ahead and cut you loose.
Konnichiwa.